This is thinkenergy, the podcast that helps you better understand the fast-changing world of energy through conversations with game changers, industry leaders, and influencers. So join me, Dan Sege, as I explore both traditional and unconventional facets of the energy industry. Hey everyone, welcome back. Did you know that we spend more than 80% of our time indoors, whether it's at home, work, school, shopping, or doing recreational activities? Currently, Canadian homes and buildings, combined with the electricity generated to power them, releases 111 million tons of greenhouse gas emissions into our atmosphere every year. To protect our environment and reduce the impact of climate change, the Government of Canada has committed to reducing Canada's total GHG emissions to 40 to 45 below 2005 levels by 2030 and to reaching net zero by 2050. The building sector is the third largest source of emissions in Canada. As we look for ways to shape a more sustainable future, heat pumps are emerging as one of the climate solutions that can reduce energy costs, lower carbon emissions, and increase energy efficiency. Now, I say they're emerging as a climate solution, but in fact, the concept of using heat pumps to transfer heat from one place to another has been around for centuries. Since its early conception, heat pump technology continued to evolve throughout the 19th and early 20th century. Today, it is widely used for both heating and cooling buildings, as well as for various industrial and commercial applications. So, here's today's big question. Are heat pumps the answer to reducing the carbon emissions of Canada's built environment? And are they being adopted at a pace necessary to achieve the 2030 and 2050 targets? Today, my special guest is Shawn Carr. Shawn blends energy, sustainability, green building project management experience with business experience as a team leader, manager, and developer. He is a strong advocate on the climate action and serves on numerous committees with organizations such as Building Owners and Managers Association, better known as BOMA, the Ontario Energy Association, and the Electricity Distributors Association. He's also the Manager of Customer Experience at Hydro Ottawa. Shawn, welcome to the show. Now, Shawn, this is pretty cool. I understand heat pump technology has been around since 1857 at a high level. What are heat pumps and how do they work?
Well, you're absolutely right, Dan. Heat pumps have been around a long time, and they're actually a proven and reliable technology here in Canada and around the world. And they're capable of providing year-round comfort control for your home by supplying heat in the winter, cooling in the summer, and in some cases, heating hot water for your home as well. In fact, it's likely that most people have already interacted with this type of technology on a daily basis. For example, both refrigerators and air conditioners operate using the same principles and technology as heat pumps do. A heat pump is essentially just an electrical driven device that extracts heat from a low temperature place and delivers it to a high temperature place. So if you think of your home as a big refrigerator, as energy is extracted from the air inside your home and transferred outside, it's going to cool the inside of your home. This is how heat pumps operate in essence in cooling mode. Similarly, if we were to talk about the heating mode, as heat is grabbed from outside from the air and moved inside your home, the temperature is actually going to increase inside your home. And so essentially what that means is a heat pump is fully reversible. It can both heat and cool. And so in essence, it has dual functionality. I think what makes heat pumps so different than other heating technologies, such as gas furnaces and boilers is that those technologies provide space heating by adding heat to the air through a combustion process. So, for example, combusting a fuel such as natural gas. And although their efficiencies have improved, they are still below 100%, meaning not all the available energy from combustion is used to treat the air. There are losses involved through incomplete combustion and heat lost in the exhaust air. So heat pumps work on a different principle. The electricity input into the heat pump is used to just transfer thermal energy between two locations. There is actually no combustion process at all. Heat pumps don't generate heat. They just redirect existing heat from one location to another. And so what that means is it allows them to operate much more efficiently. And so I thought it would be valuable just to explain kind of how efficiency is measured with a heat pump. It's actually expressed by something called the coefficient of performance, typically referred to as the COP. And what the COP is a ratio between the rate at which the heat pump actually transfers thermal energy and the amount of electrical power it actually consumes. So, for example, if a heat pump used 1 unit of energy to transfer the heat equivalent of 3 units of energy, the COP would be 3, and its efficiency would be 300%. So it actually delivers 3 times more energy than it consumes in that example. Why does that matter? Well, knowing the COP of a heat pump allows you to judge how efficiently the unit is working. And so the higher the COP, the less electricity a heat pump consumes. So it's kind of like magic. And what I'll say is a COP of 3 or higher is actually pretty common with this new era of heat pumps, even in colder locations where there is less heat to transfer. And so it's also important to understand, though, as the outside air temperature drops, so does the COP. And so by point of comparison, if you were just using like electric resistance heating, like baseboards to heat your home, they actually have a COP of 1.
Okay, cool. Now, so why are heat pumps more popular than ever right now?
Yeah, I mean, heat pumps are certainly having a moment right now, in particular, this new era of heat pumps. And that's because they are a big lever for decarbonization and reaching net zero emissions by 2050. Technology in heat pumps has advanced dramatically, making them more efficient and more affordable, even in cold climates. So in Canada, heating our homes accounts for about 16% of the carbon emissions in our country. And space and water heating specifically represent about 85% of residential greenhouse gas emissions. So replacing fossil fuel heating systems with electric options will significantly decrease household emissions. We could just use more traditional forms of electric heat like baseboards and electric furnaces, but heat pumps are far more efficient options of beneficial electrification. So if we want to drive deeper emissions cuts and we want to do it cost effectively for Canadians, switching to a heat pump is one of the most impactful ways of reducing your home's emissions. Heat pumps are becoming a pillar in a home electrification strategy.
Now, Shawn, answer this for me. Why is running our home with more electricity and choosing a heat pump a climate-friendly choice?
Thanks for that, Dan. It's a good question. I mean, first of all, there are lots of different fuels or energy types that can power our homes. We commonly use natural gas, propane, furnace oil, and electricity to heat our homes. And all of these energy types have different carbon footprints, and some are much more environmentally friendly than others. So if we talk about Canada, we have, as a country, one of the cleanest power grids in the world. And our government has committed to having a net zero energy grid by 2035. So even in regions where there may still be a significant portion of electricity generation that relies on fossil fuels, that electricity generation will steadily get cleaner and cleaner while burning non-renewable natural gas or propane in your home for heat is always going to produce emissions. And so there have actually been reports on the different ways for Canada to get to net zero. And the modeling consistently shows that electrification of heating as a necessary part of the transition to net zero in Canada's building sector. And so heat pumps specifically are critical to Canada's energy transition. In fact, they're probably critical to the world's energy transition. The technology is proven. They use up to 70% less energy than conventional home heating technologies, and they will probably become the default means of heating both indoor spaces and hot water systems in the near future. The other thing I'll point out is that air conditioning demand is rising, and by providing both heating and cooling, heat pumps can help people manage climate impacts in regions where people may not have air conditioning today, but are starting to face hotter and more frequent summer heat waves. We witnessed that with what happened with the fires in British Columbia. And those are in regions where people traditionally may have not had air conditioning.
Now, what is a cold climate heat pump, and is that what Canadians should purchase?
Yeah, it's a good question. And so advancements in air source heat pump technology now means that there are heat pump options that are, I would say, far better suited or adapted to operating in the cold Canadian climate. And those are referred to as cold climate heat pumps. What makes them different than a traditional air source heat pump is it's really just some of the equipment that's contained within the unit. So they use variable capacity compressors, inverters, improved heat exchanger designs, and controls to maximize heating capacity at colder temperatures while maintaining high efficiencies during milder conditions. And so what that means is they can still redirect heat from outside to inside your home quite efficiently, even in conditions down to minus 20 degrees Celsius or less. So to classify as a cold climate heat pump under the federal Canada Greener Homes Grant, which we can talk more about later, heat pumps must have a coefficient of performance, a COP, of 1.8 or higher at minus 15 degrees Celsius. So that means that the heat pump must maintain an efficiency of at least 180% at minus 15 Celsius. And just again, as a reminder, the most efficient gas burning furnaces out there have an efficiency of like 96 or 97%.
Okay, I've got another follow-up question here for you. Can cold climate heat pumps meet the heating demand on their own, or are there circumstances where backup heat is required?
Yeah, so I guess the short answer is it depends. Whether or not you need a backup heat source for your heat pump is going to depend, on a number of factors. For example, the type of heat pump you purchase, the climate zone you live in, and the design and efficiency of your home. So in some parts of Canada that are milder, a heat pump might be all you need, but in other colder areas, you will most certainly need a backup system. And that's because, as the temperature drops, heat pumps start to become less efficient at heating. And when the temperature gets to a certain point, the unit will shut off altogether, or it'll work in tandem with your backup heat system. And that shutoff point is going to depend on your unit, the unit that you chose. But typically, that shutoff point could be anywhere from minus 15 Celsius down to minus 25 Celsius or lower. So What I will also say is the heat pump system is not typically sized to deliver 100% of the peak heating load that your home is designed for, because that could lead to an oversized system that might cycle on and off. So it's really important, I would say, that if you're considering a heat pump, that you work with a mechanical contractor for selecting and specifying a heat pump and a backup heat source that's going to be right for your home, right for your budget and your needs. And there are many options for a backup heat system. Some heat pumps come with a integrated electric resistant heating system that functions as a backup system at very low temperature. So think of that as just like an electric resistance element, like a hair dryer that's been installed inside your duct. However, there are also natural gas backup options, such as traditional high efficiency furnaces that can be used as a backup source if your home happens to be centrally ducted. And these are often referred to as hybrid heating systems.
Now, Shawn, what are some factors to consider when deciding if a heat pump is the right choice for your home?
Yeah, I mean, I think like I mentioned a bit earlier, a heat pump is probably the biggest thing that a homeowner can do at home to help fight the climate crisis. On top of it, if you were to do the math and consider the upfront costs, the current incentives, and the ongoing energy costs associated with operating that cold climate heat pump, the choice to go with the heat pump in most cases is going to be pretty clear. That said, picking the right heat pump for your home requires planning and requires a mechanical system contractor that can help you navigate the heat pump journey and kind of guide you through that process. And the reason I say that's important is because there's a lot of different things that you need to consider in this decision. For example, do I want an air source heat pump or a ground source heat pump? Will it be ducted or a ductless system? Can I get away with just getting a traditional air source heat pump, or do I need a cold climate heat pump? What size of heat pump do I need? And should it be sized for the heating load or the cooling load in my home? What are the economics around purchasing and operating a heat pump in your area compared to another type of heating system? How long is it going to take to recover the added cost of a heat pump through energy cost savings? Is my jurisdiction planning to implement any restrictions on fossil fuel heating? Will a heat pump even work in my home? Will there be any added disruption to actually install it? Kind of like buying a car, what brand of heat pump should I go with? What warranties are available? What maintenance is needed? So I think, as you can see, Dan, there's a lot to consider. And I think despite all of these considerations, my opinion is that a heat pump will almost always be the right technology choice for your home. But making the best overall choice requires advanced planning, and it really has more to do with finding a good contractor that can help you make an informed decision rather than a snap decision when something goes wrong with your current system. This is a big purchase, and you're going to need to live with that decision for maybe 15 years or more. So it's important to get it right. And I would say that, if you happen to be listening to this podcast, that already gives you a good start, because you now know that a heat pump is another option.
How do you determine what size heat pump you need?
Well, Dan, I guess in this case, I mean, size does matter. I mean, the size is one of the most important things to get right. You can't just walk into your basement, look at the size of your gas furnace, and assume you need an equivalent sized heat pump. It doesn't work that way. The general rules of thumb, often used by the industry for sizing heating and cooling loads, generally result in an oversized system, which is more expensive to operate and harder to control for comfort. So this is why it's so important, in my opinion, just to work with an energy consultant or a mechanical systems contractor who understands heat pumps. And so Natural Resource Canada, for example, has actually developed a toolkit for air source heat pump sizing and selection. And it's to help the contractor community and the design community to determine optimal sizing needs for customers. And so the guide actually helps with defining the key air source heat pump requirements. So things like, what configuration makes sense for my home, ducted versus ductless, what are the heating and cooling loads in my home? What are the target capacity requirements? And then what the tool does is it kind of matches up good heat pump candidates for your requirements. And the toolkit actually goes as far as providing guidelines that also help with defining the control strategy for your heat pump and the backup heating requirements. And so in fact, actually the federal incentives that are available through the Greener Homes Initiative are also contingent on getting the heat distribution right. So the sizing is important, and Enercan is looking to verify that whoever worked on your project has looked at that through that lens.
Okay, something a little more technical here. Are air source and ground source heat pumps the most common types for Canadians? And maybe you can talk to us about what are some of the differences.
Yeah, I would say that they're certainly the two most common types for Canadians. I mean, air source is by far the most common type for Canadians, followed by ground source. Really, the main difference with a ground source heat pump is they actually use the ground as the source of heat in the winter and as a reservoir to reject heat removed from the home in the summer. And so rather than the air being the heat transfer mechanism, it's actually the ground. The main advantage of ground source heat pumps is they are not subject to the extreme temperature fluctuations we get with air, because the ground is a more constant temperature source throughout the year. And what that ends up ultimately doing is it actually can drive higher efficiencies. The downside to ground source heat pump typically is that they are more expensive to install. There's more labor involved, and they may also require landscape alterations. So they may not be suitable for all property types, depending on whether you've got the space and the land to be able to accommodate the loops that need to get installed in the ground and so on. So, that said, they are very efficient, which means greater energy savings, and ground source heat pumps tend to work well in almost all climates because they're not impacted by big fluctuations in outdoor air temperature.
Very interesting. Now, can heat pumps be combined with renewable energy sources like solar?
For sure. I mean, absolutely. Combining a heat pump with a solar array that will, reduce your electricity consumption and costs can further improve the business case over the life cycle of the heat pump system compared to, a fossil fuel energy system. And so, if you're in a jurisdiction with clean electricity generation, combining that heat pump with a solar system, it will result in you not emitting any net operational greenhouse gases. So yeah, I mean, pairing it up is a great solution if you can afford the capital to do it.
This is an important topic here. Now, what kind of incentives and rebates exist out there?
Yeah, wow. So this is it's becoming harder to keep up. But what I would say is it really depends on where you live, as there are many different incentives, rebates, grants and financing options that are offered by municipalities, provinces, and utilities, and they vary across Canada as it relates to heat pumps. And so I'm just going to maybe just focus on our federal program, because the federal government has created a national green energy program called the Canada Greener Homes Initiative, and it actually provides grants from $125 to $5,000 for eligible home retrofits, and up to $600 towards the cost of a pre and post retrofit home energy audit. Their program also offers up to $40,000 in interest-free loans with a repayment term of 10 years to help you undertake home retrofits. And so, with respect to heat pumps specifically, rebates through this program range from $2,500 for ductless air source heat pump system to $5,000 for a centrally ducted cold climate air source heat pump. So, between the federal incentive and any additional provincial or regional incentives and the financing options that are available, that are in this case no interest and spread over 10 years, it can make a lot of financial sense to invest in a heat pump, depending on your circumstances. And so I'll also say for our local listeners here in Ottawa, the City of Ottawa's Better Homes program also offers low interest loans for home energy efficiency and carbon reducing retrofits, including heat pumps.
Shawn, if memory serves me right, you recently installed a cold climate heat pump in your home. Did you take advantage of any incentives, and did it make the project financially viable for you?
So yes, Dan, I did install a cold climate heat pump in November of last year, 2022, and we did take advantage of the $5,000 federal incentive for the cold climate heat pump. In our case, there were two primary motivations for wanting a heat pump. Our primary motivation was to reduce our household's greenhouse gas emissions footprint. And I knew that electrifying most of our heating load using a heat pump would have the largest impact on our GHG footprint for the investment. The second motivator was the role of the federal incentive program and how that allowed us to plan the project so that I could get the system I wanted within a budget that we were comfortable with. And in our situation, what I'll say and what I'll share with our listeners is, like, we elected to pay a bit more up front because we wanted a high efficiency cold climate heat pump that was backed by a good warranty. We also opted for electric backup heat rather than a high efficiency gas furnace. And I was able to do that. I had the advantage of my electrical service was able to accommodate that choice without any additional investment. And we went as far as to also investing in a more advanced control strategy, since I like data and I kind of, believe that the proof is in the pudding with this stuff. And so, so I'm paying close attention to, how much energy my heat pump compressor's using, the fan, the electric backup heat, and so on. And so, I'll have more information to obviously share as we go through a few more heating and cooling seasons. But what I'll say is, so for our case, after applying for the federal incentive of $5,000, after we applied that to the total project cost and actually comparing the final system cost to what it would have costed to just install another high efficiency gas furnace and a traditional air conditioning system, it only cost me about $3,000 more to get what I wanted. So I have been paying attention to my energy use over the last few months, and I would say that my energy costs are comparable to what they were before. In fact, they've actually gone down a little bit, but I've also elected to maintain my gas connection to my home, right? Because we have two gas fireplaces that I have not, we've elected to keep for now. And in our project case, I've already noticed that my household GHG emissions have gone down by about 75%. And, we were able to finance the entire project over 10 years with a zero interest loan. So we're pretty happy with our decision. And what I'll say is that we've actually noticed some other intangible benefits. Our home is more comfortable, I would say, than it was before. We no longer have to worry about setting the temperature back at night and then having it ramp up before we get up. Our heat pump is designed to run at lower temperatures, at lower speeds, for much longer run times, and they can ramp up to meet the demand in your home as it's required. So they're really kind of designed to to run sort of low and slow. And for us, what that meant is, less cold spots in different parts of our home. It's kind of a constant temperature throughout, and we've noticed that difference. Also, since I completed my heat pump project, I will say that they've since announced enhanced incentives for heat pumps through our gas company. And so between the gas company and the federal program, there's actually up to $6,500 available now. So, being an early adopter cost me a bit more, but I hope others will follow.
Okay, what kind of energy savings, utility cost savings, and greenhouse gas emissions reductions could be expected from the installation of a cold climate air source heat pump?
Yeah, you're probably getting tired of me saying this, but I guess again, it depends on a lot of different factors, some of which I touched on earlier. So, things like how old your home is, how well insulated it is, how airtight it is, what type of cold climate heat pump you have, what climate zone you live in. That said, though, like getting back to your question about what kind of energy savings and cost savings and emission reductions can you expect. What I will say is last year, Natural Resources Canada published a really good report that specifically assessed the cost effectiveness, energy savings, and greenhouse gas emission reductions in a variety of different types of homes in different locations in Canada. And so the report, sort of seeked out to answer the question that you put forward. And so what I'll do is I'll just share some of the high level findings from that report. So first of all, the report found that cold climate heat pumps generate less greenhouse gas emissions and are cheaper to operate than oil furnaces or electric resistant heating in all parts of Canada, across the board, period. For the majority of Canadians, cold climate heat pumps are going to generate less GHG emissions than gas furnaces, but it does depend on how clean the source of electricity is in your province. So that's an important consideration. But the trend is moving towards our grid getting cleaner in areas where they aren't currently clean. So I think at some point we're going to reach a point where that statement's going to hold true right across Canada. The report also indicated that if you're in an all-electric service scenario, meaning you're disconnected from the gas utility altogether, the results showed that a cold climate heat pump system is cheaper to operate than a gas furnace in most regions of Canada. If you're like me in a split gas electric scenario, meaning you've maintained the gas connection in the home for whatever reason, you like having a gas stove, or you like having a gas barbecue, or you have a gas fireplace. The results showed that a cold climate heat pump system is cheaper to operate in some areas, in some jurisdictions, but in other areas, overall utility costs actually increased marginally, like roughly $100 to $500 a year. And I think that was the situation in provinces like Ontario, Manitoba, Alberta, and some colder regions in BC. So that's what the report found. It also highlighted that for a gas hybrid configuration, so people who opt to go for a cold climate heat pump with a gas backup furnace, that option may be more attractive to homeowners who opt for that split gas electrical service due to the associated savings. And so all that to be said, the report lays out the expected savings from different scenarios. So I would encourage, listeners to have a look if they want to understand kind of, what the findings are in their jurisdiction for their particular use case.
Shawn, having just gone through the process, what are some of the other things people should know if they want to consider a cold climate heat pump?
Yeah, well, I can't emphasize enough to plan early. We started planning our own project at home a year in advance. And so in our case, to start the process, we had an energy audit done, which helped validate where our biggest carbon and energy impacts were and what measures we could implement to address those impacts. And the number one recommendation in the audit report we received was to consider a cold climate heat pump. We then did some research on the incentive program requirements to understand the process for receiving the incentive. And I actually got some help from one of our internal energy consultants, and they have experience with heat pumps on the commercial side, and they helped me model the performance performance of some different units and helped me with my backup heat strategy. They validated equipment sizing, looked at my utility bills and then modeled the energy and carbon reduction savings over time based on changing energy rates. And so once we went through that process, we engaged a local contractor that had heat pump experience. And what I'll say is applying for the incentive itself is pretty straightforward, but there's a lot of demand for the program. So the process can actually take some time. The other thing I'll mention is you will also have to pay for all the project costs up front, even if the incentives and loans are approved. So the cash isn't going to start flowing from the program until after the work is actually completed. The other piece of advice I'll provide is don't wait until your furnace or air conditioner breaks down to think about a heat pump. We had a perfectly functioning gas furnace and air conditioner that was about 3/4 through its statistical life expectancy when we started planning this project. The majority of people make HVAC investment decisions at a time in crisis, such as in February when you need heat, or in July when you need air conditioning. And in those scenarios, you're going to be locked in to whatever system is available for another 15 years that won't deliver the benefits that a heat pump would. So I think those are some of the things that I would advise people to take into consideration.
Thanks, Shawn. Okay, let's move on. What is Canada's rate of adoption for heat pumps compared to other countries? And what would you say are the biggest barriers to adoption right now?
Yeah, good question. I mean, I've read some different statistics on adoption rates in Canada, but just ballpark, what I'd say is, what I've read is that there's about 750,000 air source heat pumps installed in Canada today. And by contrast, there are over 5 million homes currently heated by natural gas. And by 2030, we need more than 10% of home heating in Canada to come from heat pumps, which is more than double the current levels in order to align with Canada's climate targets. And some jurisdictions will say that the percentages need to be even higher than that. I also recently read that in the US last year, annual heat pump sales rose above 4 million units for the first time, outpacing sales of gas-powered furnaces. So policy incentives have certainly bolstered heat pump adoption in the US. And I think it's safe to say that the heat pump curve will take off even further, but we do need adoption to accelerate at a much faster pace if we want to meet our climate targets. To address the second part of your question, barriers to adoption, I think it's a combination of things. There are barriers both on the demand side and on the supply side. So on the demand side, more education, I think, is needed. These new generation of heat pumps are far better than the versions of the past, not just in terms of efficiency, but in terms of the comfort they provide as well. I think more customer awareness is needed around the benefits of heat pumps, but the customer experience associated with adopting a heat pump can also be pretty messy. And so I think that's something that needs to, if you improve. And so, for example, if you go to a contractor to ask about heat pumps, some don't know about heat pumps, or some don't want to sell them. And so that can result in a poor customer experience. In addition, often this engagement, as I said earlier, is done at a time of crisis when something is broken. You need to make a quick, impulsive decision. And so if a gas furnace or an air conditioner is all that's available in the shop, because that's what the supply chain and manufacturers are focused on, that's likely the only option you're going to have in that emergency situation. And so I think the thing that's frustrating about that is heat pumps are not that different than air conditioners. They have a few extra parts that make them a bit more expensive. So manufacturers are not prioritizing heat pumps just yet. So they don't tend to be readily available. So, again, in an emergency repair situation, that's not the best time to make a logical long-term decision that might lock you into 15 more years of higher carbon emissions. And so I talked earlier about the importance of sizing and selecting equipment properly and the inputs that contribute to that. I think that changes the sales and adoption cycle, especially if you have to plan for pre and post home energy audits in order to be eligible for these rebates. So the process is different, and it's important that it's well understood and that the planning happened well in advance so that you can make the right choices along that journey. Without the recent availability of grants and low interest loans and tax rebates, heat pumps, in particular cold climate heat pumps, I'd say have been cost prohibitive for most. But I think that's starting to change now with the new incentive programs that will make it easier for consumers to make the right sustainable long-term decision. I think, one of the other things is I also think we need to expand the workforce and build more capacity for trained installers, while expanding manufacturing, which is all going to eventually further drive down the costs of heat pumps. We need to get to a point where every air conditioner that's being replaced is just automatically being substituted by a heat pump instead. I think that would be the desired future. There are still manufacturing constraints and supply chain vulnerabilities. And in my case, I had to wait 6 months for my heat pump. And that happened to be during the pandemic when supply chains were even more constrained. But, whether it's 6 weeks or 6 months, that's not feasible in terms of the customer journey when taking into consideration this technology. So I think that these are all barriers. I don't have, there isn't a magic bullet. I think they all just need to be addressed simultaneously.
Now, I'm hoping you can add a bit of color here, Shawn. What would you say are some of the solutions to help overcome market constraints and accelerate adoption rates?
Yeah, good question, Dan. I think technology is always going to be an enabler. Continuing to improve heat pump efficiency and unlocking the supply chain will drive down the cost for that increased efficiency. And I think, that's going to be particularly important at cold temperatures, because higher efficiency at cold temperatures might mean that there is less of a need for backup heat options, or it might make those backup heat options more cost effective. And so, for example, increasing the efficiency might mean not requiring as much electrical backup heat, which could alleviate having to upgrade an electrical service, right? So that helps homeowners on the cost side, but it also helps utilities and grid planning and so on as we add more load to the system. I think leveraging data and analytics, I think there's some opportunities there as well. If utilities can get better at predicting who will and who will not need a service upgrade, it could help with system planning. If you knew that ahead of time, we could save customers time, cost, and hassle potentially. I talked earlier about just building and adapting the workforce. So thinking about how do we incent HVAC professionals to get additional training and educate homeowners on the benefits of heat pumps during routine service calls, and make it more desirable to sell heat pumps than conventional air conditioners. We can never have enough customer, education. I think education drives demand, and demand helps unlock supply chains. So if demand increases, or if manufacturers make heat pumps the first option instead of an air conditioner, that may go a long way to help the manufacturer contractor model, and ultimately consumers won't have to navigate all this complexity. So we have to make this an easy decision and a good customer experience for consumers. And one of the other ways to do that is to keep up with the incentives, the grants, the tax rebates, the long-term low interest, no interest financing, so that heat pumps just become the obvious choice and uptake continues to accelerate.
Okay, now what are the implications of the mass adoption of heat pumps on the electricity system?
Okay, interesting. Well, what I'll say is that there are certainly implications, particularly for heating. Today, we predominantly use fossil fuels, mainly natural gas, to heat our homes. And so when heat pumps are installed to replace fossil fuel heat, those heat pumps are going to increase the electricity demand in the heating season. Exactly how much demand really depends on how efficient each home is at retaining heat and the backup heat option people happen to choose. Gas versus electric, for example. If everyone went with electric backup heat and we had a long, extremely cold spell, a lot more peak load would be added to the system over that extreme cold period if everyone had electric backup heat. And so, from a utility perspective, I think the approach we are taking here at Hydro Ottawa is to investigate and model the implications of all types of beneficial electrification on the electricity system. So heat pumps and electric vehicles, for example, for different degrees of adoption so that we have a better understanding of the implications on grid infrastructure planning and the overall utilization of our grid. There are many factors that are going to determine what Hydro Ottawa will need to do to ensure its distribution system continues to be able to enable heat pumps for customers, such as understanding how customers use them, planning our system to incorporate them, and integrating other technologies like distributed energy resources and other non-wire alternatives as solutions to any grid challenges.
What's the concern about heat pumps increasing demand during peak times? Are utilities preparing for this?
Yeah, so today's grid infrastructure planning is largely determined based on peak demand, which currently occurs in the hottest periods of the summer months in most locations. That said, a heat pump draws a similar load to an air conditioner when it's operating in the cooling mode. So, if you were to replace your air conditioner with a heat pump, that's going to have a similar impact with respect to electricity use during the cooling season, like in the hot summer. On the cooling side, though, I mentioned earlier, we're also seeing demand for air conditioning rise with more heat emergencies and extreme heat events due to climate change. So that's going to increase demand as people start installing air conditioning or heat pumps where mechanical cooling didn't exist before in those homes. On the heating side, however, electrifying more of our heat with heat pumps might mean we could be moving towards more winter peaks in the future, as opposed to summer being a summer peaking province here in Ontario like we are today. The big question is how much electrification, how quick, and what's it going to cost at this scale? And marginal grid expansion is predictable, but when you're talking at the macro level, it's much more difficult, which is why we are planning for these different scenarios.
Now, Shawn, is it fair to say that heat pumps can contribute significantly to the electrification movement and Canada's net zero by 2050 goals? If so, how?
Dan, without question, electrifying our heating and cooling systems with heat pumps, as I said earlier, are the most impactful way to reduce emissions in our homes. Space and water heating represent about 85% of residential GHG emissions. A heat pump for space heating alone can reduce your emissions by about 65%. And if you add a water heater in your home, you might then be 85% of the way there. So if we want to drive deeper emissions cuts as a country, a widespread switch to heat pumps could make a big difference if uptake accelerates fast enough. This is going to require a team effort. We need stakeholders working together, not getting in the way. Governments, utilities, educational institutions, the workforce, supply chains, manufacturers, contractors, we all need to work together to ensure that heat pumps are readily available, accessible, and affordable for all Canadian households so that this becomes the default heating and cooling technology of choice in new and existing homes. So why not be proactive, think ahead, take advantage of available incentives, and consider upgrading to a GHG-friendly heating technology?
Okay, now, Shawn, We always end our interviews with some rapid fire questions. Sir, are you ready?
I'm ready, Dan.
Shawn, what are you reading right now?
I'm actually not reading a novel right now. I'm just listening to a lot of podcasts on the energy transition, Dan.
Now, what would you name your boat if you had one? Maybe you do, maybe you don't.
I would name my electric boat One Planet because we only got one planet, but sometimes we forget about that.
What is the closest thing to real magic that you've witnessed?
Well, geez, I mean, since heat pumps are top of mind right now, I would say that this technology is pretty magical.
Okay, let's move on here. What has been the biggest challenge to you personally since the pandemic began?
Wow. I probably would just say the social isolation we all had to experience, and, just seeing the impact that that had on my two teenagers who were going through high school during the pandemic, which is such an important time in their development. I think that was something that was tough on them and tough on me as a parent.
Okay, a little fun here. We've all been watching a little more Netflix and TV lately. What's your favorite movie or show?
Geez, like there's been so many good TV shows lately. Yellowstone, House of Dragons, The Bear, White Lotus, and Your Honor were all great. But if I had to pick one show as the best of all time, for me, it would be Seinfeld.
Lastly, Shawn, what is exciting you about our industry right now?
Well, I'd have to say it's the energy transition and everything that is happening to electrify our economy. It's complex, challenging, and a very exciting time to be at a utility. But this it's really important that we get this right.
Well, Shawn, this is it. We've reached the end of another episode of the Think Energy podcast. Thank you so much for joining me today. Now, if our listeners want to learn more about you, how can they connect?
Well, the best way to get me is probably by email, Shawn Carr at hydroottawa.com.
Again, thank you so much for joining me today. I hope you had a lot of fun.
I did, Dan. Thanks for having me on the show.
Thanks for tuning in for another episode of the Think Energy podcast. Don't forget to subscribe and leave us a review wherever you're listening. And to find out more about today's guest or previous episodes, visit thinkenergypodcast.com. I hope you'll join us again next time as we spark even more conversations about the energy of tomorrow.